Welcome to our lesson on modeling situations with cubic functions. You should know from our investigation in 4.6 that a volume situation is really a cubic function because we're dealing with three dimensions there, the length, the width, and the height. So three things being multiplied together results in that cubic equation there. We have an example here of a piece of cardboard that's 28 centimeters long and 21 centimeters wide. It's used to make a box, and equal squares are cut from the corners and the sides are folded up. So this is exactly like what you did with the actual paper and our arts and crafts day. All right, so first of all, we want to write the volume of the box as a function of the side length x centimeters of each square cut out. So originally, and I'm a visual person, so I like to draw my little diagrams here. Originally, we have 28 centimeters long and 21 centimeters wide, and then we're taking squares out of each corner, which are x by x units long, okay? So if I take x out of the 21, so I'm taking x off of here and x off of here, it's going to make this part, let me use a different color here, this part here, that dotted line there would be equal to 21 minus 2 x's. All right, and then we have the dotted line across here, which is a whole 28, but again, we're subtracting 2 x's away from that. So when I fold up those sides, the length of the base would be 28 minus 2x, the width would be 21 minus 2x, and then the height, when I fold up the side, the height side is just an x. So our volume, and it doesn't matter what order we multiply those in, I like to put my single x first. So that's my height times my, and it doesn't matter, base could go first, the length of the base could go first, or the width. 28 minus 2x, and the other dimension would be 21 minus 2x there. All right, state the domain of the function in the context of the question. Well, x represents the height. The height has to be bigger than 0, or you just have a two-dimensional object and not 3 dimensions, which means it doesn't have volume. I also know that if I'm taking 2 x's off of 21, I know that I can't make that dimension any smaller than 0. Like, it has to stay greater than 0. So if I look at that, I'm just doing some work on the side here. 21 minus 2x has to stay greater than 0, which means 21 has to be bigger than 2x, which then, 21x, I didn't mean to divide by x. I meant to divide by 2. Undo. There we go. Divide by 2. Divide by 2. So my x has to stay smaller than 21 divided by 2 would be 10.5, or 21 over 2. All right, so my value of x, if I solved the other equation, this one, my x could actually be bigger than the 10.5, slightly bigger, and still make that one positive, but because this one was the smaller one, that was the dimension that I picked with or worked with there. So my domain is my x, the height of the box. My x is an element of the reals, so it can be any real number, but 0 is smaller than what x can be, and it has to stay smaller than 10.5. If you go equal to 10.5, it makes the width of that box equal to 0, and again, you only have a two-dimensional object with length and height. So that should be our domain there. Now, graphically, we're going to have x-intercepts. Based on the factored form here, we have an x-intercept of 0. We have one at 10.5. We solved that over here. And if we solve this other one, if I do 28 minus 2x equals 0, and I solve that, 28 would equal 2x, x will equal 14. We're going to have another x-intercept here at 14, and these are all degree or order 1 factors, so they're all just straight cut through. My leading coefficient will end up being a positive. My function will look something like this. Okay, where v is my y, so that's my volume axis, and this is my x, which represents the height of the box, or this the length of the square that's cut out there. So this is at 0, this is at 10.5, and this one is at 14. Okay, part D, what size square should be cut out from the corners to have a box with this volume of 750? So this is telling me what to sub in for volume, and then we have to actually solve that. So let's go to the check. It was 21 minus 2x. Here we're really going to be looking at, if you do the two equations, the two lines, we're looking at this spot and this spot here. I don't have to worry about this one because it's not within my domain here. Okay, so we don't have to worry about that one. We just want to find these two values here. Okay, so put that into Desmos to solve that, and then we can state a final answer. Oops. Graph that we sketch here. All right, so my volume equals 750. So I'm going to put that into my equation, and I'm going to have 750 being equal to that x times the 28 minus 2x times, or multiplied by, and the other one was, there we go. I added an extra page by accident here, 21 minus 2x. Okay, now, I can't just go with factored form here because I don't have equals 0 on this side. So I'm going to have to expand and simplify this and see if I can actually solve for my values of x on that. Okay, so to begin with here, I'm just multiplying my two binomials together. So this multiplied by this resulted in this. Then what I'm going to do next is I'm going to collect these like terms, and then I'm going to multiply everything by the x. And then I'll bring the 750 over. I'll subtract 750 from both sides so that I can work with an equals 0 on the other side and see if I can work with that from there. All right, I have everything on one side and I have it expanded. At this point, I can try factoring. I'm noticing that all of my numbers are even numbers. So let's common factor a 2 out. They don't all have x's, so that's not going to be part of my common factor. This should be a 49, that will be an x squared. Half of 588 will be 294x, and then we're going to have a minus 375 here. Now, I've got the 4 terms. I could try factoring by grouping. If I try to group, I'm thinking I could take an x squared out of the first two. Let's see how this goes. 2. I'll take an x squared out, and then we're going to have a 2x minus 49. And out of the other pair here, I think 3 will go into those. So I'm going to take out a 3, but that's going to leave me with 98x and a minus 125. And from there, these brackets are not the same, so grouping doesn't work. We don't have a way to solve this using our algebra skills, so we're actually going to use technology to solve this one. Okay, so let's use technology. So I'm going to get you guys to use Desmos. You can put in your volume. You can do a couple different things. You can put in this equation and see what the x-intercepts are, where it's equal to 0. The other option is that you could use your original volume equation, which is this one right here. You could put that into Desmos with a y equals, and then you could do a second equation of y equals 750 and then tap where those intersect. So if I back up to the, okay, if you've used Desmos here, you should get your x being equal to 1.74 centimeters, or x being equal to 6.66. That's a devilish number. Centimeters. From there, so that's really your height. That really is your height. From there, you're going to sub that into your length, which is your 28 minus 2 times 174. 1.74, sorry. And get that value. And again, do it for this one, 28 minus 2 times 6.66. And then you can solve also for your width, which is the 21 minus 2 times the x. Okay, so you can solve for those dimensions. I ended up with, where am I going to put this though? Yeah, so you would have your dimensions for that. I'll try and type that in. Again, for the next question, use technology to solve that. Just tap on that maximum spot within the domain and figure out what that is. And then the last part here is just to state the range of the function in the context of the question. So given that we can only go for x values between 0 and 10.5, your minimum volume, your volume has to be greater than 0, but you do have that maximum based on what you found in this question here. All right, so give that a try, and then you can check your answers. Okay, so I've written my therefore statements now. The blue one right here goes with part D up above. This red one that I have here, this one goes with the what size is your, or how much is the maximum volume. And based on that maximum volume, it was 1,040 centimeters cubed. So that's what my maximum volume is, and I am going to be bigger than 0. So my volume for the range is sandwiched between 0 and 1,040.